Hi, everybody. Welcome back to the Astro Imaging channel. We've been having way too much fun in the last half an hour or so getting ready for this show. Tonight, we're very pleased to have Dr. Stella Kafka with us. She's a PhD, and she's most importantly the Executive Director and CEO of the American Association of Variable Star Observers. She's been there since 2015, and she's made a few changes. And she's going to tell us a little bit tonight about being scientists. Now, I'm going to remind you all to go ahead over to the YouTube page and start contributing to the comments section over there. But I'm not going to take any more time like I usually do introducing things and getting people ready, because I want to have more time for Stella to say what she has to say. So Stella, are you ready? Go
Already
ahead,
here.
take it. Go ahead, take it.
Thank you so much for the introduction, Alex. It's such a pleasure to be here. And good morning, good afternoon, good evening to everyone all over the world. And thank you for joining us tonight. As Alex mentioned, I am Stella Kafka. I'm the Executive Director and CEO of the AAVSO, and it is a pleasure and privilege to talk to you today. Such a distinguished and talented crowd of astrophotographers and astro enthusiasts all over the world. And I'm thankful for having the opportunity to introduce the AAVSO and try to convince you to try your hand in variable star astronomy. Let me start by reminding you that the AAVSO started in 1911 when the Harvard Observatory director recruited a group of amateur astronomers to acquire data on some of the variable stars of his interests. Since then, we have grown. There are about 6,000 individuals in our rosters, both professional and non-professional astronomers, who are interested in understanding some of the most dynamic phenomena in the universe. So you understand, we have a very diverse community. This means that we have people with different needs, different priorities, different backgrounds, different interests, different professional preparation, different habits, and different culture. We have individuals who are interested in using variable star data for their research projects. We work with educators and the students who want to introduce astronomy to their students. We collaborate with a very dedicated group of volunteers. And of course, we work with observers, those who acquire data through their telescope, CCD, or DSLR cameras, and share this information with a wider community through the AAVSO International Database. And what brings everybody together in this business is the love of the night sky and our wish to understand what is out there. Actually, as humans, we are explorers. From the very beginning, our long history started through our exploration of our own planet. We wanted to understand how big the Earth is, discover the various flavors of plants and animals, understand how nature works. And at the same time, yes?
Stella, could I interrupt you?
Yes.
Are you showing us a PowerPoint screen yet?
Yes, I am.
Oh, well, let's check how you're sharing that screen, okay? Because we aren't seeing the pictures.
Yeah, we're not
Oh,
seeing it.
that is super interesting.
Okay.
Well,
Probably just like stop sharing and start sharing again.
all right. Let's see.
You probably picked the wrong.
No, I did
Well,
not.
it wasn't showing anything, so I don't think she was actually in presenting mode.
Oh, it says that I cannot share my screen.
Okay, hold on. That's going to be me.
Sorry, you guys, I got really excited.
Yeah, I don't have any administrative controls saying that nobody can't share their screen.
An hour ago, Stella and I practiced this, so we know we can share her screen.
No, it's working now. Yeah.
There it's going. Now it's on. Okay.
Excellent.
So, go for it.
Now you get to see Flammarion's historical graphical interpretation of man's quest for knowledge of the universe. That's actually the official title. It's an engraving that shows a person who kneels down and passes his head, shoulders, and right arms through a gap between the starry sky and the earth, trying to explore and discover the realm of circling clouds. So pretty much early on in our history, in our culture, we turn our eyes upward, wondering what is out there in space, what is our place in the universe, whether we are alone or not, where are we going in the future. And From graphical depictions like the one that I showed you before, we started developing technology to help us get a better understanding of the universe. Something that also excited our imagination and our wish to come up with a viable spacecraft to help us with our exploration. But until then, we're using our telescopes, our cameras, our imagination, and our pretty pictures to probe the universe. If not anything else, you guys know the sky better than anyone else. You're astrophotographers. Through your gorgeous photos, you provide a portal to space. You are our eyes to the universe. You bring the wonders of the universe to life and help us all see what is out there through your pictures. You are actually the true ambassadors of space. Your astrophotos is a great way to communicate science in a visual and hands-on manner. Just bring it here to life and provide perspective of where we belong in the universe. And I realize there's a lot of work, dedication, talent to acquire those amazing photos. A lot of hours sitting outside in the cold and trying to make sure that all the conditions are correct. At the same time, as you're taking your photos, which reveal amazing details and structure, did you ever wonder what the processes behind the shapes and brightness variations of your objects are? Why some supernova remnants seems to be embedded in a square nebula, like in MWC 992, or some have a central ring and an hourglass-like shape structure, like in supernova 1987A, or actually some are spherically symmetrical with a filamentary structure, like in RCW 114. They're all supernova, right? Why do they look so different? Did you actually notice that Betelgeuse, the fifth brightest star of the night sky, went from this here to this within 4 months? This is actually making the 21st brightest star within 4 months in the night sky. And actually, when you take data all night long, do you ever blink your images? Do you actually see that some of those stars change in brightness within the same night in a really visible and spectacular way? So this is actually M3, a globular cluster that I'm pretty sure most of you have seen, have observed, have imaged. And there, if you pay a very close attention to this series of images that were taken the same night, you will see that some stars blink. Some stars do change the brightness within the same night. These are 4 images that we're taking back to back. So at some point, these are all questions that the AAVSO observers and researchers all over the world try to answer through the data that we acquire and analyze on variable stars. Actually, acquired data on variable stars is way much easier and much more forgiving than astrophotography. You are all among the most qualified observers to be involved in this type of work. You can use the same equipment you use for astrophotography, and the software that is needed to extract information on variable stars is extremely straightforward and very easy to use, certainly much easier than the one you use to process images. And there are many versions of this software for free. And not only that, you can do it through partial clouds, which is actually compromised transparency for astrophotography, but not for variable star work. And actually, you can do it in light polluted areas. You don't really need perfectly dark skies. You can also acquire data at all times, even during full moon. You don't necessarily need perfectly focused images. You can compensate for that by selecting a larger aperture to measure the flux in your data. And for that matter, you don't even need perfect tracking of your telescope. You don't need to stay out all night. Just 1 hour of snapshot observations each night or each other night or each week or something can suffice to get really significant data in multiple objects. So you can do this business when you are waiting for your favorite object to rise, or if you're waiting for your stars to get high in the sky, or if you need filler objects or during full moon like tonight. But for us, most importantly, your data are unique and not reproducible. They reveal the behavior of a star at the time of your observations and cannot be repeated. Therefore, they have very intensely great scientific value. I can't emphasize that enough. They reveal a very unique behavior of each star at the time of your observation, you may actually be the only person on the planet to be recording what a particular star is doing on a particular night. And that particular behavior might not be reproduced the next night. And this offers ample opportunities for extraordinary discoveries and exciting collaborations. And actually, many of our observers are included in scientific manuscripts as co-authors alongside professional astronomers, leaving a very unique legacy behind and contributing to science in a very unique way. So I would like to encourage you to think about it. So in principle, variable star observations and data acquisition and analysis is extremely easy. So here's an example. How do we do that? Say that this is one of your images acquired with your DSLR camera. Each star that you see here has a number right next to it, except for this tiny little guy here. Constant stars are those that have numbers right next to them. And these are stars whose brightness is not changing with time. Now, the one without a number that is encircled here is your variable star. Now, say that you take your image and you want to extract information from it. What do? Well, you actually draw a circle around your star, which includes the flux of your star. And then you draw a bigger circle around this particular star, which allows you to measure the value of the sky, the flux of the sky in a torus around the star. All this is happening in principle with special software. You just need to make sure that your initial aperture includes all the flux of your sky. Just visually inspect it, nothing else. Then what your software does is that it measures the flux of the star inside the small circle, calculates the flux of the sky in the torus, and then if you subtract the sky from the flux in the inner circle, from the sky from the torus, which is actually your sky value, then you end up with the brightness of the star. You do the same thing for a couple of constant stars that are in the vicinity of your object of interest, and this way you know the brightness of your variables and the brightness of your non-variables. And then you repeat it for the rest of your images and build a graph with time. All this can be done with software. So it's not going to take you days and days of processing. So in principle, what you end up doing is you build a graph of brightness versus time for some of the stars in your vicinity. So this star, the red curve that is changing is your variable, and the other stars that have unchanged brightness variations are actually constant, just a dead line. So this star is variable with respect to that. That's all there is to it. And by the way, Betelgeuse, the star that changed within like 4 months, looks like that. This is an AAVSO light curve actually of Betelgeuse. And what you see here is the V brightness data. See, this is what's important with this particular case. This is a very interesting story around this graph. We have data on Betelgeuse since 1890, more than a century. This is just a small part of it, starting in 2013. I show here only 7 years of observation just for scale. At this time, all this time, for a century, the star's brightness was between those two lines. It was changing, but not by much. And suddenly, it showed a really dramatic drop of brightness, which was actually first noticed by non-professional astronomers, by our observers, and kept us scratching our heads for months. There's a reason why this dip happened. And actually, there are a couple of contradictory theories right now trying to figure out what Betelgeuse is doing. The one thing I can tell you is that it has not become supernova, or at least we haven't noticed it yet. But the interesting part is that the star went behind the sun, somewhere in here, and when it emerged a couple of months ago, its brightness seemed to be quite towards the low limit. So it's still a little bit of down. I checked some DSLR data that were submitted quite recently. It seems that maybe it is recovery. Who knows what's going on? So this is a story that has not ended, and we're continuing to monitor this interesting object, and you can be part of that. But even if you're not interested in stars like Betelgeuse, to observe stars like Betelgeuse, pick your poison. The sky is full of all types of variables to keep us awake at all times of night or day. you can actually go from eclipsing binary star systems to exoplanet transits, spotted stars and flaring stars, pulsating variables, supernovae, cataclysmic variables of all types, those with a white dwarf progenitor, white dwarf accretor, or a black hole or a neutron star. You can observe gamma ray bursts, protostars, irregular variables, the sun, anything that is out there that is changing with brightness. I guess that my point here is if you can do something like this, you can definitely do this. And the AAVSO is here to provide you with the tools that you need in order to participate. So what kind of resources do we have for you in order to actually pursue your own observing project of program of variable star observing? First, we point out stars of interest. There are millions of stars in the night sky. How do you know what is important? How do you know what to observe? And we do that in two different ways. First, through our alert system, to which you can subscribe. It's just open source. You can just go ahead and do it even now if you want to. This actually system allows us to notify our community of observers about stars that are in need of data because something very special happens. For example, a nova goes off, and we actually need to capture the event, or about stars that need observations for specific research projects, most of the times which are requested by professional astronomers or their students, or actually individuals who are interested in doing a project. For example, in this particular case, where professional astronomers requested observation of this star, which is actually a nova, in conjunction with observations that they were acquiring with the Hubble Space Telescope and Chandra X-ray observatories. Actually, this is a light curve that our observers acquired it. And these observers were included in the relevant manuscript that was published. It's a great opportunity to be part of an international collaboration of professional and non-professional astronomers. Everyone contributes in a very unique way, and we all learn together. The second way is for you to select your own targets of interest, especially if you have a limited amount of time, say 1 hour, you just need filler targets. This is where our target tool comes into play, which is again open source and free for anyone to use. And through this tool, you get target information, meaning right ascension and declination, which constellation the star is, minimum, maximum of the star's brightness. And this way you can actually adjust or select the stars that you would like to observe based on your equipment. You have a DSLR camera, a small telescope, a CCD, bigger telescope, whatever you want. The variable star type, so that you will know more or less, if it's known actually, sometimes it's not. The filter and mode of observations that we would like to have in our database, the observing cadence, how frequently we will recommend for that particular target to be observed. You can observe actually as frequently as you want, whatever you want. But if you are looking for guidance, here's something that you can get through that tool. When that particular target was observed last, whether it needs observations. And actually, we are giving you information on whether that particular target has not had data during the recommended cadence through this flag. What happens here is that if a star does not have data through the recommended cadence, then the flag is red. Once data is being submitted in our database, then it flips and it becomes green. Black are stars that are in conjunction, so they're behind the sun, you cannot observe them. We also have some notes that are attached to alerts. If you subscribe, you sign up, and you tell us where your observatory is, you can actually get targets that are visible from your unique location. So you can get your targets of interest to you. You can also sort this particular table by variable star type if you're interested in specific variable star types to observe, such as eclipsing binaries or cataclysmic variables, or just stars that are presented or were recommended through our alert system. So this is a tool for you to actually be able to plan your observing program. If you are, again, in the middle of the night and you have an object rising in another setting and it's not the right position, you just don't want to waste time, this is another way of actually using your telescope time and using your skills in order to provide something for science. We also provide tools for our observers that would facilitate your observations. This is our variable star plotter, VSP, which provides finding charts and appropriate comparison stars for each star field based on your equipment, whether you have a CCD, a DSLR camera, et cetera, et cetera. We have tools for data uploads through WebObs. We have tools to visualize your data. This is our Lightgraph generator, which plots your data alongside data of other observers. You can actually zoom in and out. You can plot partial light curves on all data that are available in our database. You can plot specific filters. You can also see who else has observed this star with you, or you can plot only your data and take a look at them. And also, we provide information on all types of variable stars through our Variable Star Index, which is a super catalog including the known information of more than 1.5 million variable objects right now. By the way, if you discover a new variable star in your star, which is actually quite likely because we haven't mapped the entire sky, right? You can submit it to VSAT and you can get credit for your discovery. So you are listed as a discoverer of this star. We also provide tools for observers. We offer you software to process and analyze your data. VFOT is a tool that actually processes digital images and extracts light curves from time series of CCD or DSLR. And VSTAR allows you to plot your own light curves from your own computer or from our database and do some analysis of your own. And you're interested to get your hands dirty with variable star data, just to play a little bit and understand their behavior. For all of the above, there is training material to either refresh your memory in observing techniques or get you acquainted with various software tools or different ways of observing. We have manuals that span from CCD and DSLR observations, observation of exoplanets or the sun. The sun is a variable star. Also manuals on VSTAR and VFOT, all our software. We also have online courses, each lasting 4 weeks. They're based on our forums, and they also teach you all of the above. So those courses run throughout the year. And we have a very active peer mentoring system, which pairs experienced observers with beginners. For some of us, it's useful to have an observing buddy when we start with a new mode of observation, no matter how experienced we are. I started my own visual observing program in 2016, and I did have a mentor to help me navigate the night sky and find the objects that I needed to with my binoculars. We also have a journal which accepts manuscripts from both professional and non-professional astronomers on all types of stellar variability. If you do your own research project, actually you can publish here or just read interesting results on variable stars from our community. We have article types from review papers, variable star research, new instruments, methods and techniques, education and outreach, solar astronomy, history, biography, and some summaries of dissertations. For those who are interested in publishing, we actually introduced a double-blind refereeing process, as in the author doesn't know who the reviewer is, but the reviewer doesn't know who the author is. So this way we are removing biases from our reviewers or our authors when it comes to the reviewing process. We have templates both in Word and LaTeX. The journal is open access, so you can actually go and download and read articles that are accepted immediately when they are on our webpage. And it does appear in NASA's ADS system. So when other researchers are interested in learning what you've learned, they can actually go ahead and read it and further their own work. For our community, we also have observing sections. You can learn more about all types of variable stars and actually groups that the AAVSO is reaching out to through those observing sections. There's information about all types of variables, including exoplanets and high energy targets, such as gamma ray bursters, novae, supernovae, alongside information on instrumentation and equipment, which is a new observing section here, which is actually of interest to some of our observers who really like building their own instruments and understanding how different types of images work. Actually, this is the information, part of the information that you would see in one of our observing sections. The example is from the Young Stellar Objects section, so showcasing information. So you can get some general information about the stars in here. You can get a target list with stars of interest that are in need of observations. You can get a way of join the section, join the discussion if you want, or even follow the discussion through our forums. You have a contact information of the observing section leader, a person who is extremely knowledgeable on how you can observe this kind of objects and what kind of bizarre behavior they're showing. And you have actually a list of all types of resources that are associated with that particular observing section, that particular subject matter. So please take advantage of this. And not only this past summer, oh my gosh, it's the end of August, I can't believe it. We're running as a webinar series around our observing sections. These are free for all, so I invite you to register to the remaining ones or go to our YouTube channel for recordings of previous ones. You can learn a lot of information, you can get a lot of information on different variable star types, get a sample of what our observers are observing, what they're interested in, and actually perhaps tempted to get involved. I would actually also like to give a shout out to our annual meeting. We invite you to attend our annual meeting. This year it's going to be a virtual event. It will take place in November, and it will be accompanied by 2 workshops, one on data mining and one on spectroscopy. Let me leave you with some final thoughts here. We live in the renaissance of variable star astronomy. There are multiple space and Earth-based missions that aim at exploring the night sky, and they will produce a plethora of mysteries. And there are not enough professional telescopes to acquire the data that are needed to solve those mysteries. The AAVSO, ground-based small telescopes, is an essential resource for research all over the world. And if not anything else, we need more observers to actually help us understand the skies, only those data. So only with the help of people like you, we can understand, probe the universe. So in the limited time that we've had, I hope I managed to convince you to try your hand in variable star astronomy and join us in our quest to explore and understand the universe. The AAVSO will be by your side along the way. All the resources I described and even more can be found and downloaded for free on our webpage, www.aavso.org. I would like to encourage you to become a member or support the AAVSO through donations and help us continue our work providing all those resources to observers worldwide. And also, if you have any questions or need help to get started, this is our email. Feel free to drop us a note. It will be directed to the appropriate person. You know, variable star astronomy is really fun and very rewarding and provides a unique perspective, unique information on some of the craziest, most dynamic objects in the universe. So for those of you who are thinking of getting started, just do it. You have nothing to lose and a wonderful world of wonders to discover. So from there, I'm going to thank you for your attention. I'm going to stop sharing my screen, if I manage my screen sharing, and go back to my friends on YouTube.
Hi, and I'm back.
Hey, and you're back.
And as soon as you stop presenting, I'm going to start presenting my screen here. So I'm going to present my entire screen where you can see Stella again because she's on my screen. But now I'm presenting my screen, so I'm going to go over to one of my favorite places on the internet, our very own website. By the way, the reason I'm doing this, actually, I'm going to go over here first. The reason I'm doing this is because Stella wanted to get a few minutes where she could read through the comments in the comment section and see what kinds of things were going to be coming up in her questions. Eric is going to be arranging the questions so that we do get all those questions covered. But Stella wanted a minute or two to look through all that stuff. So while I'm here, I want to remind you that this is the place where you can ask all of your questions. And of course, hey, this is your club. This is the Astro Imaging Club. Every Sunday night we get together here at 6:30 if you're in California, and at 9:30 if you're back east someplace, and at what is it, 1:30 in the afternoon over where Terry is, and on Monday in Australia. So from all over the world, people are gathering, and this is a place where you can gather and ask questions of your fellow astro imagers. So we encourage you to do that. On it, you'll find a place where you can make a donation and you can put in custom emojis, and down at the bottom, You can subscribe. We're up to what, 9.4 thousand subscribers, and as you all know, I want to get to 10,000 because I don't know what happens at 10,000, but that's my goal, and I got to set a goal to keep going in life, you know. So anyway, and don't forget to like the things that we're doing, and so certainly subscribe to the Astro Imaging channel. Let's go back over to the Astro Imaging channel website itself. There's a couple of things that you need to know about. One is, as you know, we always need presenters. And if you hit the contact button here and you give us your first and last name and your email, make your comment here and send it to us, we can get back to you. If you have any questions about what was presented here tonight, if you want to know more about the Astro Imaging channel, but most importantly, if you want to participate by sharing your knowledge, sharing your skills, and your skills don't have to be top of the line. You don't have to be Adam Block and Warren Keller and Stella. You don't have to be at the top of the business. What you have to be is somebody who loves what they're doing and wants to share it with other people. I'm real happy that we have some people lately, at least once a month, somebody's coming along and volunteering to be a presenter here. They do a good job. Some of our most popular shows have been people that, you know, how I started in astro imaging on the cheap, things like that. It's really important that we get presenters on that. And here is how you can get a hold of us. And for those of you who are wondering what we've got coming up in the near future, we got, as I remember, this is the week with Stella. We started with the first of 4 women in a row, and we're proud of that because we, like the AAVSO, as Stella was telling us about, we want to have diversity. If we don't have diversity, all we're going to have is a bunch of the same people. And if we got the same people, when those people go away, we aren't going to have anybody in our hobby. So we need you to join in. We need all sorts of people. We need young people who are doing astro imaging. We need people of color. We need women. We need everybody, as well as us old white farts. Okay, that's cool too. Okay, we'll take you. But let's get everybody involved in this. Don't be afraid to sign on. Linda's going to be, Ellie's going to be here next week. She's going to be telling us about Green Bay's telescope pointing and meteorology systems. We've been wanting to get somebody to tell us about meteorology for a while. Linda Thomas Fowler, who is out there right now.
Metrology, not meteorology.
Meteorology?
No, metrology.
Metrology. Okay.
Different.
That's right. It's Carrie's job to tell us about meteorology. Anyway, metrology. God, I wish I could read. Linda's going to be here next week. She's out there. She's a regular, and she's one of us, and I'm really proud to have her finally coming on. She's been asked several times. Carrie Ann will be here the next week. Hey, Tolga, we haven't figured out what she's talking about yet. We'll have to get back a hold of her. And then Brent's going to tell us about AstroPixel processor. Uses it. He knows a lot about it. Andy's Astro's coming in. He's another Australian's going to be coming to visit us. Amy will be here in October. We've got some blank dates in there. Hey, let's fill it up. We got everything. Let's fill it up until between now and Christmas. All you got to do is hit the contact button and sign up. Excuse me. Now, I think that by now Stella's probably had an opportunity to run through her list of stuff that she wanted to talk about. I'm going to stop presenting right there. Stella, take over again. And it's, I think, no, wait a minute. I got to turn it over to Eric. Eric's going to be asking the questions. Eric, you want to ask your questions?
I have a few.
Before you start, Eric, I have to tell you that I just subscribed to your channel. So you guys are going to be on my radar now. Now you got one more person.
Thank you. Thank you. A question that came up, it's kind of in the middle of your presentation. As far as filters that you can use, are there preferred? Because most of us out here are using like LRGB or narrowband filters. So if that's what we're using, is data from those filters useful? And which ones are preferred?
You can do LRGB, especially if you're doing if you have a DSLR camera. You can actually use clear, not use a filter at all. Usually we're using the BVRI Johnson or Cousin filters, and these are the ones that most of our observers with CCD cameras are using. In principle, you can, as long as you can transform your filters, I think that you're good.
There's one-shot color included in that, like DSLRs are one-shot colors shot through a barometrics.
There you go. Yes.
Okay.
Yeah.
Okay. Can you submit data without being a member?
Yes. Yeah. You just create an account and ask for an observer code. Anyone can get an observer code. And actually, I would encourage people to get an observer code. This is a unique identifier that individuals have. And this is the way that we can give you credit for your data.
So if you submit data and then somebody uses it, they get back to you and say, hey, we used your data and this is the result?
And actually, every time somebody downloads your data, you get a weekly report on which of your data are being downloaded and what they're downloaded for. So I have 25 data points in the database. Please don't laugh. And they are visual data that I acquired through my binoculars. They do have some that I haven't submitted yet, so bad me. But actually, I just received an email, my weekly report, telling me that 4 of my star data were downloaded to a project, one for a figure and one for a manuscript that's going to be submitted to a scientific journal. So for me, it's actually a way to know that people are actually using my data.
So
my
you
25 data points.
You can submit visual data. That seems a little more complicated.
For those of us who have been raised in astronomy using digital data, visual data is much more challenging. I have to tell you. And for those of people like me who don't know how to navigate the night sky, I don't really know which way is north. Trying to find my star was very challenging. At the same time, that's why this is where my mentor came in. So I had a mentor who was actually standing right next to me with their binoculars, and they were helping me star hop and find my variable. So at some point, I took advantage of the AAVSO resources. I'm really grateful for that program to be in place. And it's extremely, extremely satisfying seeing with your own eyes, experiencing this change in brightness. We're very used to actually watching a screen. I live on a screen. I have my phone here, I have my iPad there, I have 2 different computers in front of me. And you know, everything is digital. You're just measuring, you're relying on your software. But when you're looking at the night sky and you see a star's brightness change with your own eyes, that's a completely different experience, a very esoteric experience, very personal. I think that's why people get so excited with Betelgeuse. Because, you know, one time it's the brightest star or the second brightest star in Orion, and then it's way, way fainter than Rigel. You can see the difference with your own eyes. So yes, visual observing is a little bit trickier, but at the same time, I find it extremely satisfying.
So many of our astrophotographers used forms of automation like ACP.
Mm-hmm.
Are there any scripts that are put out by AAVSO that we can plug into things like ACP or other automation software where it says, go do this, and then we run it and submit the data?
The AAVSO does not provide scripts. However, there are many observers out there. So if you're interested in a pre-programmed observing schedule, we can find someone who could share their scripts with you. The reason why we don't do it is simply because there's so many stars. Depends on what you're interested in. We don't want to confine people on something that is very biased. I mean, what stars are we going to put in a pre-programmed SCP program, SCP software? Would be something that is interesting to me. That's a little bit too selfish, don't you think?
No, it's just a question that came up. So what
I
about
understand.
telescopes? I mean, whatever telescopes we happen to have will do the job, whether the focal length is 200 millimeters or 2,000 or 4,000.
There is something for everyone out there. I actually, if you have a DSLR camera, that would be much more appropriate for stars like Betelgeuse.
The software you mentioned, VPOT and VStar, is this kind of plug and play software, or are we actually drawing circles around stars manually?
For VFOT, it would be nice to visually inspect and make sure that your circle, your inner circle, is outside that dot. That is your star, especially if you're out of focus. So you can increase the size of your circle, and pretty much the way that you do it is just you give it a numerical value, 3, for example, and if you see that it's too small, just go up to 4, go up to 5.
So is there, if you have a star field with 10,000 stars,
Mhm.
is there any software where you can just say, here's my observation, and then let the software crank out the information for you?
So VFOD is doing that. So pretty much what he says that this is my star of interest. It's in these particular coordinates, right? And actually the AAVSO recommends comparison stars, constant stars per field. So these are my constant stars in my field. Go.
I guess I was asking if, here's 6 hours worth of data.
Mhm.
I'm just submitting the data and give me the plots afterwards. I'm
Yeah.
not going to do any work. Will it do that, or do I have to identify stars, or will it look for variable stars in 10,000 star field, 10,000 stars in a field?
Right. So most of the time we have 1 or 2 main stars of interest, even in this particular star field. So what you do is actually say, these are the 2 stars. This is the field that I'm submitting, right? These are the stars of interest here. They already do an astrometric solution, and you just let it run.
Yeah, and
And
you
you
don't
wake
even
up in
have
the
to
morning.
do like in the software, you just select you said you choose a catalog. There's a catalog, like a little drop down, and you pick I can't remember, GCDS, something like that, and it goes in and it looks at the plate solved solution and identifies which stars are the variable stars and which stars are the constant stars. So you just have to uncheck all the ones that you're not interested in and didn't have enough signal to noise ratio and stuff like that, and just leave the ones checked that you're actually interested in. So the amount of work is very, very little, honestly.
And or actually, what I would say is just let it run all the stars and inspect the light curves, and then you know which one's junk because you're just picking up
like
noise.
if the
Right?
uncertainties are really high or the SNR is really low, you can throw those out.
You can just throw those out.
Do I take it that I've collected a whole bunch of sub-exposures, and then I look at one of these sub-exposures and specify that I want this star and that star to be compared. Now go do it.
Yep.
Okay.
And like you don't need a lot of sub-exposures unless you're trying to go after like a really dim star or something. I generally take 5. And then or like 5 to 10, and then I average them, and that's the image that I use for the VFOT tool will do the averaging for you, and then I use that just to increase the signal to noise ratio. Like I probably spend 10 minutes on target a night. That's it.
Stella, does the data have to be calibrated or raw out of the camera?
They have to be flat fielded and dark corrected.
Okay, thank you.
I think there might be a couple more. I think I got all the questions that I made notes of, and then Stella, of course, answered a bunch more before we actually got to this point. And of course, there are lots of comments on what a great presentation you did, and you got a few people excited. I wouldn't be surprised that some of the people are already signing up to do this, including me, of course. I signed up while you were on there.
And I see 2 of my friends there. Hi, Barbara. Hi, Andy.
Alex?
Yeah. I did have a question. Do you guys work only with stellar things of one variation or another, or do you also do asteroids and maybe something else?
We do.
The concept sounds an awful lot similar.
Here's a very interesting question to ask an astronomer, because we have to be very accurate answering. So, fun fact, when the AAVSO was founded, our founding fathers, they were gentlemen, actually wrote in the charge of the AAVSO that we are going to be studying variable stars and kindred objects. There was some wisdom in those old people that we don't understand what's going on in the night sky that is changing. So we are interested in anything that is changing. I was going to say that is outside our solar system, but the sun is part of what we're doing. So the sun is part of our solar system. But other than the sun, we don't do asteroids or planets in our solar system. Technically, exoplanets are not stars, right? It's like you see the drop in the brightness of a star because of a rock that goes in front of it. Gamma ray bursters, supernovae are not stars, they're dead stars, they're done. Cataclysmic variables, white dwarf accretors, white dwarfs are dead stars, I guess. Black holes are dead stars, neutron stars are dead stars. So other than asteroids, and solar system objects that are not the sun, we'll accept everything. I'm trying to be as accurate in my description as possible. Like, definitions.
I'll try to unpack that in my brain and see what that actually said.
So no asteroids. How about that?
No asteroids. Okay, that's because I know some people who do asteroids on a regular basis, and the process is very similar.
Yes,
it's
exactly
virtually the same thing. Yeah.
And actually, I can tell you that asteroid observation it's more complicated than variable stars, because you have to move your telescope in a specific way that tracks a really fast-moving object. So, yeah, and asteroids are much fainter.
So if you get really, really good at AAVSO, you can go over to.
Well, actually, if you get really, really good at AAVSO, you go and do astrophotography. I think astrophotography is extremely difficult. My goodness. I've
only done enough of this to be able to say, yeah, I did it once. I basically tried to track algol for a while, which gets dark and gets light again. But it isn't really very difficult at all. The software is made for just click, click, go do the work. Oh, here's my graph, and that kind of thing.
But what I find fascinating, I mean, I started astronomy in graduate school. I'm a physicist. And the first time that I had clear skies and I was sitting in front of my monitor and I was watching images coming down, I was looking at my monitor and I hadn't had my software ready yet. So no image processing while things were coming. And I was wondering who else is observing that particular object the same time that I did. And it occurred to me that I was the only person on the planet that was looking at that particular object at that particular time. So I'm the only one who would have information on what it's doing. I love astrophotography. I mean, all of us started by just looking through a telescope at the moon, right? And we all grew up with a poster of a nebula on our walls. And we all were amazed just looking at a beautiful galaxy, all those colorful images with dust lanes, the central object, just mind-blowing. You bring in something that you're trying to imagine in life right there. But at the same time, the more you do it, the more you're getting better at it, right? So you can produce better images, you can produce you can reduce your data with better techniques. When it comes to measuring variable stars, you do it once. You have one chance to capture that particular behavior, and it's unique. And it's unique for the generations to come. Betelgeuse, we wouldn't know it was doing something weird if we didn't have 100 years of data. And even with that 100 years of data, trying to understand why that one star was doing what it was doing for 100 years, and then why on earth it changes behavior, is something that is an ongoing research project. And I can tell you, in 100 years from now, people will be wondering what's going on with Betelgeuse. And that is only one object, just one. The universe is so vast. There's so many amazing mysteries out there. It makes me feel like a detective, just Sherlock Holmes right here. My only problem is that, every time I think I know the answer, new data come out and actually I don't know the answer. But I'm learning, right? I'm learning as I go. And this is the most powerful feeling. And I'm learning not alone, with people from all over the world. all over the world. Astronomy does not have borders, doesn't have boundaries. We all learn together. I just happened to spend 30 years in school and specialize in something. That's the only difference between me and my observers. And I love collaborating with these absolutely fascinating, dedicated, passionate people. You know, it's fun and it's work, but it's fun. So there. Sorry, I don't get me started. That's how it goes.
No, you're just the kind of person we want to have that has that level of enthusiasm, which is really contagious. And I'm sure spreads out to all the people that are listening. Certainly
Yeah.
is to me.
Wonderful. Thank you. You know something? I know that there's some papers in preparation on Betelgeuse. I can come back in 6 months from now and tell you all about it.
Thank
If
you.
we
Oh yeah.
if we have figured out, if
That'd
we
be so
figure out,
cool.
if you figure out what's going on, because chances are,
Well, it'd be interesting to see like people to kind of get a glimpse inside that scientific process and see like why two different papers can say different things but both still be true, you know, and also just to see what kind of different conclusions people have come up with and stuff like that. I think that'd make a really interesting presentation.
Tell you, Stella, this is what we want from Betelgeuse. Please explode.
I know, right?
We want it to explode. I don't care what else, dim, bright, explode, or it already has, because 400
Exactly.
years ago, you know, I know. But we want to see it explode. I want to see the kind of supernova that is epic.
Oh, my friend, just be careful what you're wishing for, because if Betelgeuse exploded 700 years ago, so its light's coming now, it is going to be once in a lifetime or in humankind experience. No one has seen anything like that. But at the same time, it's going to be another source of light pollution in the night sky. It's going to be brighter than the moon. So for those who are interested in dark time,
Uh-oh. Didn't
me-
think
Yeah, I was
about
gonna say,
that.
Let me
everyone
jump,
has photography
let me
for a
jump in
while.
here for something. Hey, let me jump in here for something. Let's talk about light pollution and the moon. I know a guy, Eric Coles. He loves to take pictures, and he's got lots of really cool stuff and an observatory, and he takes pictures. But every once in a while, like almost about once a month, this big old moon comes out, and he can't take pictures. Can he use that time with the full moon out there and everything to take pictures?
Absolutely. That's one of the things that I was actually describing during my presentation.
Yeah.
You can definitely take variable star observations during full moon. Go observe Betelgeuse tonight,
And from the city.
please. And
And
from a
from the
city.
city.
Yeah.
Yeah. So
Now, there are some times where you just can't do that. For example, if it's completely overcast,
mhm. Yeah, but
unless you have a cloud blower.
the point is that you're talking to a bunch of people right now, and this is going on YouTube, and it's going to be out there for I don't know how long. They've all got telescope rigs and cameras and tripods and everything, and they don't work, for half of the month because of the silly moon. But they could be doing something with that fun stuff, right? They could be
Absolutely.
staying up and watching that, or even having Sequence Generator Pro or
Yeah.
Prism or something like that take care of it all by themselves.
Yep. Yes.
You know,
young people.
even in nights like tonight where the moon is pretty full, it's really not very high in the sky. And even though if we take a bunch of, say, luminosity images tonight, it won't be suitable for an image, but there's plenty of stars in the field. And when you're doing relative brightness, I can't see why all of that data would be as useful as new moon.
Exactly. So the moon is it's a blue light source, right? But at the same time, within the field, the small field of view where your variable star and your comparison star is, it's more or less the same transparency, the same kind of light source. So since you're doing sky subtraction, as Eric said, it's a comparison science. At some point, you're going to get useful data from your variable, even if it's like 10 degrees from the moon, 15 degrees from the moon. It just
Okay.
brings your sky up. It's like light pollution. You know, when I was a graduate student, I wanted to find a way of spray paint the moon. It didn't work, but still.
Okay, we've had, I think, a chance to ask a lot of questions over there. If you've got any come in, please get them to us because we're about to wrap it up. Did you have anything to say in conclusion here, Stella?
Just do
Anything?
it. As I said,
Okay.
try it. You should try it. It's
Okay.
it's a fun occupation to have. It's extremely important for science. It's extremely important actually for all of us who are trying to understand how the universe works. Please keep sending us data and join this party. It's really fun.
Okay. I'm going to turn this back over to the lady in charge of all this, Molly Wakeling. Molly, we got
Alrighty.
it. Are we ready to go? Wait a
I
minute.
will
Eric,
take it out.
Olga, who was that?
Oh, I didn't say anything.
Okay. Okay. Molly. Good night, everybody. We'll see you next week. Ellie's going to be here and she's going to tell us about the Green Bank telescope and some metrology. Bye.
Yeah, that's gonna be super cool.